Science Guy.
Science rules. Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Especially strong wind, or if you found yourself in a blizzard, or a downpour, or if you've ever heard thunder, or seen lightning, well, that means you're in a storm! Storms happen all over the world every day. Without storms, life wouldn't be anything like the way we know it. The world's air and water wouldn't be nearly as bad. Storms are extreme weather. They're caused by the heat of the sun, water in the air, and the spin of the earth. Take a look at this. It's our miniature, gigantic, extreme storm system simulator of science. Now, when the sun is out, like during the day, it heats up the surface of the Earth, as simulated by these red lamps. That makes the air near the ground get warm. Then cooler air from surrounding areas flows in and forces the warm air way up, like this. Now, way up, it's a lot cooler because it's closer to space. So we get this flow of air moving up and down at the same time. These are the conditions that make storms. Now, we're simulating a lot of sunlight over an enormous area of land with huge masses of air. Now, in real life, the air flows in from different directions, so it can start to spin like this. Wherever you've got heat, an atmosphere, and a spinning planet, it really churns things up. Storms are extreme weather. Extreme weather!
Welcome to Extreme Weather Theater. What, you ask, is extreme weather? Well, this is extreme weather. Thank you. This, too, is extreme weather. Thank you. So is this. Thank you. This has been Extreme Weather Theater.
Storms are extreme weather patterns, baby. They'll soak you rotten.
From time to time, a mysterious thing occurs over the eastern Pacific. It affects the weather worldwide. It is El Niño.
El Niño.
Normally, trade winds blow over this part of the ocean, keeping it cool. But from time to time, it stops. Then the sun beats down, warming the sea, which warms the air. And no one knows why. It is El Niño.
El Niño.
When this happens, fish die. Fish
Die.
and storms rage all over the globe. It is El Niño.
El Niño.
Now, I must go. Adios, amigos.
El Niño.
Unseasonably warm and stormy weather we're having at this time of year, don't you think?
This strange weather phenomenon, my friend, is the work of none other than El Niño.
El Nino?
El Niño. A mysteriously warm area of water in the Pacific. It can affect world weather patterns, causing unseasonably warm weather and more frequent and powerful storms. El Niño.
On planet Earth, there are storms the size of Texas, hurricanes and typhoons. They're formed when huge areas of the open ocean soak up a tremendous amount of heat from the sun. Cool air squeezes warm air up. Warm air carries water vapor with it. When the vapor turns back into a liquid, when it rains, it releases a lot of energy high in the atmosphere, which helps drive the winds of the storm. These storms are so big that they get spun by the spin of the Earth.
More energy being released every second than from a dozen atom bombs.
Now, the winds are moving so fast that these storms end up with a hollow spot right in the middle called the eye of the storm. The winds are calm there, while they're really howling around the outside. Now, if one of these storms moves from the ocean onto the land, they can really tear things up.
When a cold air mass meets a hot one, look out, baby. It's stormadelic.
Hey, there aren't any anchovies on this menu. What's that all about? Oh, no. Not...
The missing fishies, my young friend, are the result of mysteriously warm waters, killing creatures like your precious anchovies from Alaska to Peru. It is none other than El Niño.
Lightning is electricity, the flow of electrons. Now, let's say that these people are electrons. They're all negative. They have the same charge, so they're repelling each other. Right now, there's nowhere for them to go. But when the door opens, they spread out. The same thing happens in clouds. Let's say this is a cloud, and this rubber belt is keeping it chock full of electrons. Now, they'll spread out if we let them. They spread out. The easiest way for them to do that is to find a path to the ground, like this. Oh no, it's a big dark storm cloud coming our way! Quick, everyone, get in the house! Pow! A bolt of lightning. Now the lightning heats up the air and makes it expand so fast, it's like an explosion. Thunder. And thunder can get pretty loud. See, we were going to make my bones light up, like in the cartoons. But instead we went with this makeup effect.
When you're caught in a thunderstorm, a tree may look like a nice shelter, but it's not. Since lightning strikes the highest point around, a tree is a prime target. So don't stand under a tree during a thunderstorm.
What you should do is get short and make as little contact with the ground as possible, so the electricity is less likely to choose you as a path than, say, if you were under a tree or standing in the field or lying flat. So just squat like this and let the lightning find something else to hit. It may feel a little uncomfortable, but it beats getting zapped.
I bet those kids downstairs are shaking in their shoes. You know, whenever angels go bowling, we make thunder.
No, we don't.
We don't?
No. Thunder is caused when charges due to static electricity are built up in the clouds and the surface of the planet. When the difference in the charge is big enough, you get a bolt of lightning that instantly heats the air up to 5 times the temperature of the sun. That creates a sound wave known as thunder.
Well, gee, all this time I thought my 710 splits were the cause of explosive sound. Well, they're sure going to get a rainstorm down there.
Huh?
I'm going to cry. And when angels cry, the rains come.
About that rain thing, we need to talk.
It's a twister! Tornadoes take place when air masses of extremely different temperatures come together. See, the sun shines right through the air and warms the land. The land acts like a stove and heats the air above it. Now, instead of the hot air getting squeezed and rising, it's held down by a slab of cold air. So if conditions are right, the hot air punches a hole through the cold air and rushes up through it like a bathtub drain, upside down. If that happens, take cover, my friends. You got yourself a twister. When that happens, my friend, take cover, because you got yourself a twister.
Some storms spin because of the Earth's rotation. Oh, behave, you little twister.
The stuff we have here is our most recent area of research, and it involves work at the University of Colorado to model tornadoes in the laboratory. We chose water because water and air act the same way. You can work with either one of them and get good results. We discovered that some of these lab tornadoes make very, very loud sounds. And we're trying to understand that because we've discovered that full-blown tornadoes in the atmosphere also make sounds. But when we deal with real tornadoes, the sound we're expecting is going to be so low that we require an electronic ear to hear it. This is our electronic ear. All of these hoses that are going out from it, like an octopus's tentacles, are the sensing element that all feed into this microphone. All storms are really potentially dangerous in some way, but we might be able to listen to sounds that could save lives.
You can see how a tornado works. Just fill up 2 2-liter pop bottles.
These plastic ones are cool because you can do that.
So have a so-called friend help you fill up the bottles. Now, have a friend help you empty the bottles. Make it a race. Tip the bottles over at the same time. Keep one bottle steady and give the other one a twirl. Ready?
Okay, go.
See, when you get it spinning, the water drains much faster. The same thing happens with tornadoes. When air gets spinning, it spins faster and faster to make a wild, spinning storm.
I won.
The Earth isn't the only place with storms. No, they happen all over the solar system. This is the planet Jupiter. It's over 1,300 times the size of the Earth. And for hundreds of years, astronomers have observed a great spot. It's a storm, a hurricane. And it's over twice the size of our planet. It's been raging for hundreds of years. And you're saying, well, why doesn't it die down the way hurricanes do on the Earth? Well, there's two things. First of all, Jupiter is huge.
Jupiter, twice as large as all the other planets combined.
Secondly, it's spinning very, very fast. It takes Jupiter only 10 Earth hours to go all the way around. So the winds on the surface of Jupiter are really moving. They're going fast enough to sustain this gigantic storm for centuries on another planet. Wow.
There's the sun up in the sky. It's heating places all around at different rates, so wind is made. Water evaporates into the sky. Storm clouds forming in the sky because cold air pushes warm air way up high. Barometer's been falling lately. Storm is on the way, and maybe we should all get ready, baby. Here comes a hurricane. Now we're at the rain is pouring. Look out, cause the wind is blowing. Cold and warm air mass is flowing. It's all mixing up the atmosphere.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some mesocyclone advection currents to quantify. See ya!
Produced in association with the National Science Foundation.
Gonna get right into the Lipton condensation level. Right on, right to the meter. The half meter. And that way we'll know for sure what induced this blizzard. Yeah. Because the air goes up, and then after a while, it goes down!
I'm buying lunch today. In fact, I'm feeling pretty good. I'm buying lunch for everyone. Hey, everyone! Lunch is on me.
I'll take a steak to go!
Extreme weather! Wow. Storms. Extreme weather! Storms.